Welcome student. Today we are going to learn fourth part of science chapter 1, that is matter in our surroundings. Let's start the topic. At first we know temperature. What is temperature? It is defined as the degree of hotness or coldness of a body, and it is measured with the help of a thermometer. Generally, we use thermometer while we are suffering from fever, In our books, temperature scales are three types, but generally fourth type, but in our book it is three types. First Celsius, Kelvin scale, and last one is Fahrenheit scale. The question may be convert the 293 Kelvin into Celsius scale. So use this formula, we can easily solve it. Then comes to effect of change of temperature. Here we can use some terms, that is melting point, boiling point, latent heat of fusion, and latent heat of vaporization. First we can see a activity. You look this nearest picture. Okay, first we take small ice in a beaker and suspend in a laboratory thermometer so that its ball is in contact with the ice. Then we start this heating on low flame. Then we note the temperature when it starts melting. Then we can record or we can note any copy. What we will observe means the ice is a what? Solid. This ice melts in water, means solid converts to liquid state. Now put a glass rod in the beaker and heat while stirring till the water starts boiling. Then again we can record our observation, means this water converts into vapor position, means the temperature at which a solid melts to form liquid at atmospheric pressure is called melting point. And you know the melting point of water is 0 degree centigrade. Then comes to latent heat. Latent heat is the amount of heat released or observed during change of state of a substance. Here in this experiment, the temperature of the system does not change after the melting point is reached till all the ice melts. When we continue the heat to the beaker, that is, we continue to supply heat, and this heat gets used up in changing the state by overcoming the force of attraction between the particles, means as this heat energy is absorbed by ice without showing any rise in temperature, and it gets hidden into the contents of the beaker, and this is called latent heat, means this heat quantity is hidden. Then comes to latent heat of fusion. It is the amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point, means it is a latent heat, means in here the heat is hidden, and the 1 kg of solid that is converted into liquid. Then comes to boiling point. The boiling point is the temperature at which a liquid starts to boiling at the atmospheric pressure, means water converted into vapors, and it is also called as a Buck phenomenon. Next comes to latent heat of vaporization. It is the heat energy required to convert 1 kg of liquid into gas at atmospheric pressure at its boiling point, means here the water converts into vapor. and this heat is hidden, so it is called latent heat of vaporization. Next comes to sublimation. It is a change of solid directly to vapor on heating and vapor into solid on cooling without passing through the liquid state is called sublimation. Means here the solid directly converted to vapor without get liquid. Here we can see this activity. First we take some camphor or ammonium chloride and cross it and put it in a china dish and put an inverted funnel over the china dish. Then a cotton plug on the stem of the funnel. This is so in figure. Now we heat slowly and observe. What you observe? That a change of state directly from solid to gas without changing it into liquid state. Means here the camphor or ammonium chloride vapors is directly changes into vapor without getting liquid form. Means this process is called sublimation process. Examples of sublimation is camphor, ammonium chloride and naphthalene ball also. Comes to effect of change of pressure. If we compress a gas in a cylinder, then the distance between the particles of a gas is reduced and finally gas is liquefied. Here see this picture. Here it's 3 cylinder. Suppose we can increasing or decreasing this pressure and it can change the state of matter. First, in this cylinder the gas is filled and we applying pressure and reducing the temperature, this gas convert into liquid, means it converted into liquefied gas. Example LPG, you know it is used for in cooking. Means the cylinder can fill up the LPG gas and here it is here this gas is in liquid form and it is kept close in cylinder. And CNG gas also, okay. And in hospital oxygen is needed for the patient, so the oxygen cylinder is transported to the hospital and this oxygen gas is liquefied in the cylinder and it is used to the patient. Then goes to interconversions of state of matter. It is a phenomenon due to which matter changes from one state to another state and back to its original state on altering the condition of temperature and pressure. Means the change of matter from one physical state to another physical state. It is called interconversion of states of matter. Here solid converts to liquid and liquid converts to gas. Then it's reverse, means gas converts to liquid, liquid converts to solid. Okay. In this picture we see when the solid converts to liquid, this phenomenon is called fusion, and liquid converts to solid, it is called solidification. Next, solid converts to gas, it is called sublimation, and gas converts to solid, reverse form, it is also called as sublimation. Next, liquid converts to gases is called vaporization, and gas converts to liquid, it is condensation method. Then comes to change of state from solid to liquid on the basis of molecular structure, means inside the molecules how the state change from solid to liquid. When we heat any solid substance, the particles gain energy and it starts vibrating inside it, and their kinetic energy increases, due to which the intermolecular space increases and this intermolecular force can become decreases and the substance get converted into the liquid state. Next comes to liquid state to gaseous state. When we heat any liquid substance like water, the particles obviously gain energy. As a result, their kinetic energy increases. When we heated some solution or some liquid substance, that it gain kinetic energy and it starts vibrating, and its greater amplitude due to which their intermolecular species increases and molecular force decreases. Thus it get converted into gaseous state from liquid state. Then comes to evaporation. Evaporation is the phenomenon of change of a liquid into vapors at any temperature below its boiling point is called evaporation. Means it's the change of liquid into vapors at any temperature below its boiling point. And it is a surface phenomenon and it causes cooling effect. Here it's 4 factors that affects evaporation. First one is increase of surface area, increase of temperature, decrease in humidity, and last one is increase in wind speed. First we see increase in surface area. We know that evaporation is a surface phenomenon. If the surface area is increased, then the rate of evaporation increases. We give example, means while putting the clothes for drying off, we spread them out. Okay. Next one is increase of temperature. With the increase of temperature, more number of particles get enough kinetic energy to go into vapor state. Means increase in temperature, the evaporation also increases. Next, the rate of evaporation increases due to decrease in humidity. Means humidity is the amount of the water vapor present in air, and the air around us cannot hold more than definite amount of the water vapor. If the amount of the water in air is high, then the rate of evaporation is decreased. Last one is increase in wind speed. Means the rate of evaporation increases with increase in wind speed. It is a common example. Means clothes dry faster on windy day. Means increase in wind speed, the particles of water vapor move away with the wind and decreasing the amount of water vapor in the surroundings. Clear? This is all about your evaporation and its factor. Next the question will arise, how does evaporation causes cooling? During evaporation, particles of the liquid gain energy from the surroundings to overcome the force of attraction between them. As a result, loss of heat energy occurs in the surroundings. This is why evaporation causes cooling. Means during evaporation, what happened? Particles of the liquid gain energy from its surroundings and it causes cooling. Next question is, what happens when you pour some acetone on your palm? You know acetone? Acetone is a volatile liquid, so it evaporates quickly. Acetone means what? The nail remover. And it volatiles very quickly at room temperature. So when the acetone is put on your palm, it evaporates and our palm feels very cool as it absorbs energy from our palm. When it evaporates, it suddenly evaporates and it causes cooling. Next question, why should we wear cotton clothes in summer? During summer our body keeps cool. We know that during evaporation, the particles at the surface of the liquid gain energy from its surroundings or our body surface and it's changed into vapor. Suddenly water means sweat directly changes to vapor. Means the heat energy equal to latent heat of vaporization is absorbed from them and it's our body becomes cool. And in summer season we wear cotton clothes because cotton is good absorber of sweets, and it causes cooling, and it is easy evaporation occurred. The next question, where do we see water droplets on the outer surface of a glass containing ice cold water? You know, ice cold water tumbler, at the outside the small water drops are seen. Here the water vapor present in air, on coming in contact with the cold glass of water, it loses energy, okay, and it get converted into liquid state, which we see as water droplets. It's all about your chapter 1. Okay, I hope all students can understand this chapter. If any doubt about this chapter, so please comment in comment section.